All right. Today we are going to learn about validators and serializers. And this is just going to build on what we saw yesterday with Django models. And today we're still focusing on the data piece of Django, right? If Django models give us like an object relationship mapper, an ORM, so that we can write OOP code to talk to the database. This adds more logic in our Django Python code to validate the data that before it goes into the database. And we'll learn about something called serializers that help us transform our data, like say into JSON to say send it an HTTP response over to our front end. Um, and we'll be learning about serializers today as well. So the plan is part one of the lecture, we're going to kind of review database models. We're going to learn about validators and Django's very rich library of built-in validators. We're going to see how to create some custom validators, and we're going to see how to write some tests. And I know you all got a bit of a preview with that yesterday, and there was a wrinkle or two, and we should be able to sort that out today. Part two, we're going to learn about this amazing library called Django Rest Framework that we're going to be using because really we're going to be using Django to build a REST API, um, which we'll talk about more and more as we get deeper into the course, into this module. We'll talk about serializers. We'll see how to build serializers, how to use serializers from Django REST Framework, and how we can in fact use serializers not just for like turning data into JSON to say, if we're sending data from the Pokey API to our React app, but when we get data from our React app, we can turn that JSON into an object and then save it and turn it into a model and save it to our database, which is pretty cool. Any questions about the plan for today? All right, cool. So I'm going to kind of go through some slides just to sort of review stuff. I've started building a Django project that builds on yesterday. I'll do a brief review and spin it up, and then we'll dive into the good stuff. So we spent a lot of time yesterday making models, and this is sort of the workflow, right? You have to create your model first. Let's pull up our nice little annotator. You have to create your model first. And in here, as you can see, we've got a model of a chair. What we're going to talk about today is validating the models. We saw this yesterday, sort of, right? We can add constraints to our fields. And in fact, we saw that blank constraint was a little different because that actually wasn't in Postgres. Um, and validators build on that. Validators all happen in Python and with Django before it even sends the data to Postgres, right? So that's what we're going to see today. And then, once we make a model or modify a model and create or modify our validators, we need to run the make migrations command. And can someone remind me what make migrations does?
Doesn't it just convert that data into PostgreSQL
Close,
tables?
close. There's two commands, right? And in fact, let's take a look at this Pokemon model that I've made here. So this is from yesterday, where we've got Pokemon with a name and a level, the date they've been captured, the date they've been encountered, a description if they're captured or not, some helper, dunder, repper, and dunder string methods, a level up method, and a method to change its caught status that will flip it from captured or not captured. Um, if I look here and just to give a very quick overview of my Django project to help orient us, um, I've got my virtual environment directory, my Django project directory, and my README. Right now on the terminal, I'm inside the Django project directory where manage PY is, because that's where we're going to kind of do most of our command line work. So that's here, right? I've got manage PY. I've got a Pokemon app, Django app that I created, and the project itself. Over here, I've set the database to Postgres in Django settings. I've set it to the Pokédex database. I've in fact created the Pokédex database. but if we look at it, there's no tables or anything in it yet. And then all the way up here in installed apps, I added Pokemon app. And I've installed my like dependencies and stuff. And I should probably just make requirements txt just for sort of best practice. Our requirements txt just really has Django and Psycho PG3 that talks to Postgres for us. So, um, how can we tell just from looking at these files if I've created any migrations or not, or my Pokemon model?
In the migrations, they'll be like sequential numbered.
Yeah, exactly. Each migration file is named sequentially, and that helps Django run stuff in order. So if I run python manage.py make migrations, what is this command going to do?
Makes a migration?
Yeah. Now, does it talk to Postgres or do anything to our Postgres database?
No, not yet.
Right, not yet. And Chase, you're thinking of the next command we're going to run in just a minute, right after this. And I realize I'm being a little pedantic, but that, that's the nature of the beast, for better or for worse. Once we create our migrations, we'll run this migrate command, right? And then that will actually apply the migrations we've created to the database. Um, it looks like I have an error here, so let's fix this real quick. I may fix it in a very fast and lazy way. Um, let's see if this quick fix from time import time zone fixes it. If not, I may just get rid of the default. Int object has no attribute now. I'm going to very quickly use the internet to help me solve this. And it looks like I need to import from Django utils. I just got confused about where to import from. So let's try from Django.utilities, right? From Django utils, import time zone. See if that fixes that error. And we're good to go. And so now I've created a migration. We don't have to modify this, but it's kind of nice to see it. If I look at our database, we can see nothing has changed. Let's go ahead though and apply the migration. Right. And the goal of the migration tool is like when we have a live database, this gives us a lot of control. It's like Git for our data schema. And now over here, I've got all these great tables, right? We can look at our Pokemon table, Pokemon app, Pokemon that has all these nice fields. I can do select star from Pokemon. Actually, even better, instead of that, well, we'll do select star because the Django shell, I have to restart it every time when I fiddle with stuff, so it's a little brittle. And there's no data here, right? So how can I solve this problem? How can I put some fake data in my database to make our lesson more interesting?
Features.
Can't you go into
Yeah,
this?
Fixtures.
yeah, I knew what you were talking about, Jason. I love it. Everyone's great minds, right? Great minds think alike. We need some fixture data. And I've gone ahead, I've created a fixture directory here in Pokemon app. I've just copied over what we had yesterday with Pikachu and Charmander. And you know what? We are probably going to want to add a couple more properties to these fields because, in fact, our data model has kind of grown and evolved.
Wait, I just fixtures. I was thinking we went
Yeah,
into shells
The
and
shell, that's what I was
data.
thinking too.
yeah. So that's a great point. We absolutely can do that. If I wanted to go into the shell, and in fact, let's just go ahead and open up a shell real quick. And we did see this yesterday. Um, Let me go into our project and do Python manage.py shell. Let's see, air loading Psycho PG2. Interesting. I might have something. Uh, I think I have something simple wrong. So let's fix this real quick and then we'll circle back because I thought we had Psycho PG2 installed and everything set up. We sure seem to be able to talk to our database just fine. So let's see what the issue is here. I could have sworn Psycho PG was installed, but maybe I hadn't. And now our server certainly seems to run and run without air. So I must have thought I installed Psycho PG. Somehow it was even in requirements.txt. Maybe I had forgotten to activate my virtual environment. Um, or in fact, actually, that's probably the issue here is I might have the wrong virtual environment activated. That's the danger with opening like multiple shell sessions. And actually, if I had to guess, that is almost definitely the issue here.
Regarding that, does it make sense like when you're creating a new project to just name the virtual environment after like the project?
I honestly don't think so because while on the one hand, I get that it would be nice because you can see this here. I think the right answer is, and let me just show this right now, in fact, with iTerm. So way back in the beginning of the class, um, we modified this shell script, this ZSHRC file, or it might be a bash RC file for Windows folks. So I think we got everyone on ZSH. And every time you open up a new terminal or a new shell session, this bash script gets run. And all the way down here, it's a little hard to see, but we added this source, we added this line of code that activates a virtual environment in our home directory. Can everyone see what I'm talking about here? And this was great, right? For OOP, it made life easier. It looks like I actually have it commented out here, though I wonder if I have like another one somewhere hiding around. But now that we want to start getting in the habit of making a different virtual environment directory for each project, which I know it feels like a bit of a pain, but I think it is an important habit. We probably want to either comment this line out or delete it entirely. I'm not sure if that's the issue that I was running into there, but I think that is something worth doing. Um, I think it's just better to have it be the same name. Also, VS Code will find this name automatically. Um, I realize there is a bit of a gotcha there, but I think it's better than the alternative. To give a long answer to a short question. And now if I want to run my shell, let's see here. Let me go into the project. And now we're cooking. And now we're in our shell. So
Oh, so the Pokemon, that's the dumped data or
say that again,
the
Morty.
fixtures, dumped data or whatever. There's like a dump command or something from yesterday.
Uh, yeah, the dump command is something else, but there is the
Oh,
load data command with fixtures. I think that's what you're thinking about.
so it's a different way to make Pokemons or whatever. I don't
Exactly.
know. Oh, okay.
Yeah. And the key thing to remember here is let's pull open this diagram and let's take this and modify this a little bit. And this is how data gets into Postgres, right? From Django. We use a model and we stick it in. But I've got a couple different ways I can do this. I could do it, in Django shell, where maybe what I do is I do, Pika equals Pokemon name Pikachu, Pika dot save, right? And when I do save, we're using our model, our Pokemon model to then save this to the database. But I could also, and I'm just sort of using circles here to make this look different, use fixtures from the command line. And I believe that command will be something like, you know, Python manage py load data Pokemon data dot JSON. And then what we have here is, we have some fixture data. And again, I'm making this real simple. And then what that fixtures command does is it takes that JSON and passes that data to, again, our Pokemon model, which then like creates a model object and talks to the database and passes the data in to save it. And does that sort of help illustrate like the different ways that we can get data into our database leveraging Django models?
Yeah, absolutely. My brain completely skipped fixtures. It's weird. I don't know.
Yeah, no, there's a lot that we're throwing in here, right? Like Django is heavyweight. It's got a lot of layers. Um, I think Django is going to be, in terms of just the amount of layers and the amount of stuff, probably like the most complex thing we'll see here. Because again, it helps us to build skyscrapers, right?
Thanks.
And so, yeah, no, great question. I'm sure other people were curious about this as well. So I think this was good to review. And, I fixed a couple bugs along the way that will keep us on track. So this was good.
This may be me misinterpreting the directories you have, but how does manage.py know which app to dump the JSON file into?
Yeah, good question. It will look in the fixtures directory of all the apps for the file with that name. Um, Let me add a couple. I think I'll just leave these as is. I think I'll just add one more Pokemon because if we look at our model, it will create default values for date encountered, captured, description, and so on. So let me just throw in what's another Pokemon like Blastoise? Do I have that right?
Is
Yeah,
there
let's throw in Blastoise, and their primary key is going to be 3, and we'll make them like level, I don't know, 5. Blastoise and Eevee are going to get the short end of the stick here. And we'll do Eevee, which I remember a previous student explaining to me. And I forget why, but they're supposed to be awesome. So hopefully, if I don't have any JSON errors, I've got 4 Pokemon, and I need to make sure I change that primary key. And now, Kenny, like you were saying, I'm going to make sure I'm going to run Python manage py load data and the name of the file. And I do think the way Django did this is confusing, to be honest. Uh, but what Django is doing is it will look for in every single app for a directory named fixtures, and it will look inside all of those fixtures directories for all the apps for the file that matches this name. And then it will load it into our database. And now if I hop over here to pSQL, we've got Pokemon. And if I want to use the Django shell and I do Pokemon objects all, we've got our Pokemon. Yeah, and this is a good review, right? Because there's a lot of moving parts here. I think having the cheat sheets up and open as we do this is really helpful. So we've actually gone through a lot of these steps, which is awesome, right? Um, we reviewed making a model. We're going to talk about validators in a minute, but we reviewed migrating, and later we're going to talk about testing. And this is sort of like a constant workflow that you do, right? And it might just be adding one field or one validation. It's not like you create a whole model every single time. It might just be, I don't know, I don't know why we would add like a footstool to a chair, but I might just add one thing to an existing model. But each time you do, um, you'll need, and you may or may not need to tweak the validators, but you'll need to go through this whole flow. And really, this flow is the main thing, right? Make a change, make migrations, apply migrations, run your tests.
Hey Adam, I have a question.
Yep.
When we were building models yesterday and we built methods, are we going to implement things that we did in OOP like decorators into all of this, or is that not applicable to Django?
We will see decorators somewhere else in Django. They might show up in models I can't remember off the top of my head, but you definitely see decorators and those other things used in various places in Django. Yes.
Thank you.
Uh, totally. At the end of the day, we can use whatever Python code we want. It just may or may not make Django happy. But yeah, decorators do pop up. Um, so we've talked about a lot about this actually, right? And these are the key questions as you think about this. And it's the same thing when we were designing our data schema with SQL, thinking about what entity does my model represent in the universe that I'm creating. It is useful to know enough SQL to think about how it looks in the database. And then what fields does my model need for it to work the way that I want it to? Um, Now we're going to look at validators. Um, Validators are how we can specify rules about what is or isn't valid data. And it goes beyond the sort of constraints we've seen with SQL, though there's a lot of overlap. So let's take a look at some validators. And I will just go ahead and pull up our curriculum here. And in today's lesson, we also have this sort of workflow that I mentioned. Um, Django has really, really good built-in validators. And let's take a look at just how many validators they have. Um, in fact, let me add like a min value validator so we can see what a validator looks like. And um, then we will look at the Django built-in validators. So adding a validator is pretty easy. Let me kind of get this out of the way so it doesn't interfere. All I need to do is validators, and I need a list because you can have multiple validators. So these are both arguments we're passing here, right? When we create an instance of this integer field class, I do need to import from Django. Oh man, I need to remember the import path from Django core. Import validators. There's a lot of validators and we use them a lot. So it's easiest to create an alias for them. So I'm going to import this big object that has all the built-in validators and alias it to the name V. And then I can do V dot min value validator. And we'll set a limit of 1. I wanted to just make sure I had the syntax here right because each validator can be a little different. So as easy as this, what I've done now is before this data goes to Postgres, Django, when we're modifying our Pokemon, will check to see if this is a valid value for that level. And we'll talk in a minute about how Django does that. But let's take a quick look at the list of built-in validators. And as you can see, there's a lot. The Django docs, again, are great. And actually, can someone maybe give me, like, just want to read this paragraph out right here real quick?
A validator is a callable, sorry, that takes a value and raises a validation error if it doesn't meet some criteria. Validators can be useful for reusing validation logic between different types of fields.
Yeah, thank you, Tim. Awesome. So there's a couple key things here, right? First off, this raises an error. And in fact, if we look in the Django docs, there's a whole validation error class that explains what's happening. And so that gives us an opportunity to handle that error with a try except block if we want to. As is mentioned here, validators can be reused. If I have an email validator, I might have an email field on a whole bunch of different models, or first name, a name validator. And we can reuse them either by using the built-in validators or writing our own. We'll write our own validator in just a minute, but you can sort of see a preview of what that looks like here. We have to follow a certain syntax, a special format. Namely, our validator has to, if something breaks the rule, in this case, if the value is not an even number, if it's not divisible by 2, we need to raise a validation error with an error message. And in fact, you can see the example here of how they do this. We use the validator that we create here.
Is this essentially, sorry,
Yeah, no,
is
no, no, go
this
ahead.
is this essentially you're writing code for Django to convert into an SQL check?
Very good question. No, this does not get run into an SQL check. This is actual Python code that Django runs before sending any data to SQL.
Hmm.
Yeah, very good question. And that's an important distinction. This is Python code that gets run. We'll see. And in fact, I think that maybe takes us to this next question of how validators are run. And let's just go to this validating objects section. So this isn't quite as, complicated as a React component lifecycle, but there's actually a whole validation process. And my apologies that we're looking at an old version of Django. For this, it doesn't matter, but maybe we can just get to 5.2. There we go. There's a whole validation process, and there's in fact a bunch of built-in methods on the model class that our Pokemon inherits from, right? Every model we create will inherit from this model class. And so the validation methods are one called clean fields that will validate individual model fields. We might then have rules around how different fields interrelate, or like, does every single field pass the validation rules? So the model as a whole gets validated. I'm not quite sure I think this happens outside Postgres. I think Django does a uniqueness check for us in Python code. We could look at the docs to see exactly what it does, but I don't want to open that rabbit hole right now. But this part might actually be talking to Postgres, so I might have to amend what I said, Tim. And this part definitely does. The constraints are part of Postgres and the data model. So these two are definitely Python code. These two, it may be validating against our Postgres data schema. And you can see how each of these sort of serves a different role and is useful. And Django has given us a method named full clean, as in like we're clean, as in there's no validation errors, like our data is clean and ready to be put into the database. And if we run this method, it validates everything. And we'll demo this in just a minute in the Django shell. We'll add some validators and then we'll play around with this stuff. But just to finish walking through this workflow, because this is, I think, sort of the key concept around validators. We can do an isValid call, but really we want to call the full clean method. And we do this all the time. And yeah, I don't really want to get too much into the details of the rest of this. It's not worth doing. by the way, as you can see, there's a lot of built-in validators. This one will validate like a decimal number. We can validate for a valid file extension, minimum value, maximum value. That something's an IP address, um, a URL slug, an email validator, right? There's a whole lot of built-in validators, and then the regex validator, which is super flexible. Um, but so to use this effectively, yesterday we learned about the importance of always doing .save in writing code. What we actually want to do now is we want to always run our validation before saving. And if I don't do this, what ends up happening is if I send invalid data to the database and it violates a database constraint, it'll reject it. If there's a Python rule, that's an issue. But this also saves us making extra calls to the database with data we know to be invalid. I know it can seem a little frustrating to have to do this manually, but again, like Django is giving us the control so that if there is, for some reason, some situation where we don't want to be using the validation logic, we have that option. So to use validators, we have to call full clean. And I'll walk through doing this manually in just a minute. I think let me pause for questions, and then we can add a couple validators, and then we can play with it in the Django shell. Sound good? So how are
Validators
people feeling? What's it?
are validators. You said you always have to run full clean, so all validators are going to be methods within the class. They're not class elements like description, captured.
Well,
They're going to be run against those to make sure they're good.
we use for each field, we can add validators. And in fact, let me add a couple more validators, and I think that'll help sort of illustrate this. So, like for name, these aren't going to be probably Python code. Null equals false. We don't need to add, but blank equals false actually adds like some Python logic validation. Um, for level, I've added a min value validator, right? That says the level has to be at least one. Let's add a second validator to our level field, and let's have it be a max value validator. And let's say that the Pokemon level, can't be more than 100, right? And so right now, when we do level up and we do full clean, um, for each field, it will run these validators. Let me add a couple more, and then we can run it and play around. Um, for description, I think we should make sure this can't be too long and it's not too short either. So let's add some validators here, and let's in fact use the same ones we did before. Let's add a min value validator. Excuse me, this should actually be a min length validator. And let's say our Pokemon description has to be at least 7 characters long. I can already tell I'm going to run out of space here, so I'm going to reformat the way my code looks a little bit. I'm going to do it JavaScript style. I'm not sure if this is actually the recommended Python way, but I know we're familiar with this now from React. And let's say that our description can't be more than 150 characters. So we've got validators now on level and description, right? Let's try these out and play around and see what it's like. And to do that, I'm going to use the Django shell. And to do that, I am going to quit and restart the shell. And note, by the way, let me run Python manage py make migrations. Let's see, something changed with the level field, which I'm actually a little surprised by. So it looks like these validators did get added to the migration, but I don't think these get added to the schema. We can find out when we apply the migration. Maybe I'm confused here. So let's clear this so we can see this clearly. And let's look at our Pokemon table the way it currently is. And we can see what we've got, right? We've got not a ton of constraints, really just a bunch of not null constraints. If we see something change for level, then we'll know that some of these validators do indeed add constraints. Note, by the way, that we have a migration file here for our level field, but these changes to the description with min length and max length don't seem to have been added, which is interesting. So I've applied my migration. If I go to pSQL now, let's look at the table. And it is still the same, right? So the migration file is sort of tracking some stuff for Django, but we haven't added any constraints to our Postgres database. And I am just going to make sure that I didn't forget anything. So I think we're good to go. And let's go ahead and run our Django shell. From the Pokemon app models, let's import Pokemon. And we can do Pokemon objects all. And that gives us all of our Pokemon. Let's just grab Pikachu. So now I've got Pikachu. So let's break some rules and see what this is like. Let's start with the level, right? The level has to be greater than 1, less than 100, or maybe greater than or equal to. Let's set Pikachu's level to -5. Note that no validation logic kicked in, nothing is complaining. Watch what happens if I run this full clean method on Pikachu. We get an error and we see a validation error down here. Level ensure this value is greater than or equal to 1. So there we see full clean doing its job and applying validation logic to all the fields. Let's see if we can save Pikachu. That didn't throw any errors. And in fact, if I go here and I do select star from Pokemon app Pokemon, let me get my query right. All the way down here, I see that Pikachu's value is -5, even though we added this min length validator to the level, right? So I just want to emphasize here, like most validators, your working assumption should be the validators are in the Python code. And the reason this is useful is because sometimes it's easier to change Python code than it is our data model. And again, imagine that we have the Poke API database and we have 100,000 Pokemon in there. Well, changing the Postgres data schema with 100,000 Pokemon in our database, that might be tricky. But changing like our Python code and our validation logic is a whole lot easier, right? So there's layers, and the
I'm
closer you
sorry.
get to the center of the onion, the more conservative you want to be. Yeah,
I'm a little confused because it seems like the validator didn't work if it still was able to save it as -5.
right. Great question. So the validator's job is not to keep us from getting, well, I shouldn't quite say. So what the validator does is it runs some Python code. When I run this full clean method, it will run all of the validators and it tells us if the data is valid or not. That's the only job of the validator, is to run Python code for our Pikachu object saying, is this data valid? It's not the validator's job to keep us from putting bad data in the database, that's still our job as a programmer. So that's why we need to, when we're writing our logic, we need to run full clean and then run save. For example, let me put the Pikachu level to 50, which is valid. If I run Pika full clean, we don't get an error thrown. And now if I do Pika save, we don't see an error. If I run my query again, Pikachu's level is 50. Let's use this, let's see, level up increases. Let's set Pikachu's level to 100. I can run Pika full clean. 100 is a valid value. I'll go ahead and save it. And just for fun, we can see here in pSQL that indeed Pikachu's level is at 100. Instead of manually changing the level, let's use this level up method that we wrote. Pika.level up. Now my Python code throws an error, and it throws a validation error saying level, ensure this value is less than or equal to 100, because we tried to bump Pikachu from level 100 up to 101. So by like writing methods like this where we can put in the logic of how we want to do, we can use the validators in our Python code to validate our data before we put it in the database. Does that help break down a bit more what's going on, Jack?
Yes.
Yeah.
I have a quick question too.
Yeah.
So this might be like down the line a little bit, but say we have like a very specific type of data we want to input, like say social security number, and it's like you want to make sure it has three numbers, a dash, two numbers, a dash,
Yeah.
and four numbers. Are we able to like create our own validators?
Yeah. And in fact, that's what we're going to look at in just a second. And we would use a regex for that. Yeah. Great question. What other questions are on people's minds, or what else are we curious about? How are we feeling about validators and sort of the flow here?
I guess I actually do have a question again.
Yeah.
So when you ran the level up, I see how we got the validation error because it wants it to be less than or equal to 100.
Mhm.
But did it still then run this self dot save and still change the value to 101?
Great question. And in fact, I should have shown that. It did not. If we look here in the database, we can see Pikachu's level is still at 100. Um, and if we look at our code and think about the flow of execution, we know that the validation error was thrown by line 33. And at that point, once the error was thrown, execution was stopped, and we did not get to line 34 that saves it. If I had written my code this way, it would have run the validation after saving, and it would have saved it to the database, right? And that would have been just a programmer error to write the code that way. So it is going to be a little annoying at first, and then you'll get used to it. But you always want to do full clean, and then you want to do save. And again, while it can feel a little onerous, Django is giving us the tools um, and, and to be able to design things exactly how we want. And the more you write helper methods like this on your models and elsewhere in your code, then this doesn't become so bad. And also you get used to it over time.
Okay, so that leads me to another question. Like, if you could scroll up, boom. So when we do like, I don't know, the char field max length, like, how are those different than doing a validator? Because I feel like if it doesn't meet like the requirements for like, I don't know, like you say, max length should be at least whatever, like for your Pokemon name.
Right. If I'm understanding your question, these are indeed validators, and in fact, we can
Like
break
line
them.
7, when we first do like our models and we're getting our data
Oh,
saying that our
this.
data has to, yes.
Yeah, great question. Um, I think this is where it can be. a little tricky initially to keep track of stuff. Um, let me let's make some boxes. So over here we've got Postgres, and over here we've got Django, and over here in Postgres I've got my Pokemon table, which I'll name just Pokemon at Pokemon. And then over here we've got our, and I'll make this really big so we can fill it up. We've got our Pokemon model. So models do two things. Validation is one of them. The other thing that they do is they do indeed create our data schema in Postgres. And if I hop over here and I do describe to look at Pokemon, and we look at the data schema, note that the data schema is character varying 255. And if I wanted to change the max length here to, let's say, 100, I could change that. What I would have to do then is create a new migration, right? Because I've modified a model, and then apply the migration to the database. And now if I go to pSQL and I run this same command again, we see that in our data schema in Postgres, the constraint has changed for the name, right? Now the Pokemon name has to be 100 characters or less. So some things we do here in the model do indeed affect our Postgres data schema, but validators really do not. And so the flow is, and let's in fact make this, let's add the browser over here. And let's say the user like creates a Pokemon and we send an HTTP request over here over the internet and it looks something like this, you know, name, Charmander, level 5,000. And in fact, let's pretend that name is greater than 100 characters. I'm not going to type that out, but let's just pretend that's the case. So this data gets sent over here, and the first thing that happens is the validators. And this happens in our Python code, and we would get a validation error. That would be like level min length or max length validation error, right? And this would happen in the Python code when I run full clean. Um, let's say the user fixes that. Like we give the user a message, they do level 50. Well, now that validation error, those validators pass, right? And the next thing that full clean does is probably before saving to the database. I don't know if Postgres has a way to validate data before saving it. It may or may not, but it passes the data onto Postgres. Let me draw it like this, right? Let's say, and then in Postgres, we hit the, name constraints, name, it's like varchar 100, and we hit our Postgres data schema constraint. And then that would kick, Postgres would not save this, right? And it would tell Django that, and then Django throws another validation error. So, like, there's two stages here. One is the validation logic that happens in Python, and that's mainly the validators. And then the other is the actual data schema constraints. I realize I've kind of been a little fast and loose with the diagram here, but does that help sort of break down the behavior of
Yeah,
what's
you
going on?
pretty much hit it on the head for me. Thank you.
Awesome. Yeah. And I think this is a bit weird and tricky to get used to, right? And the context here is it's cheaper to do validation here in Python. Think about if we are, I don't know, Netflix or Facebook or some massive company and we have hundreds of thousands of users. We really need to be thoughtful about how often we're hitting the database to read stuff or write stuff, right? Because there's a lot of traffic. So the more that we can, kind of like clean and validate and do stuff up front, then the more we can like reduce the load on the database. Because why go and try to save something if we know the data is invalid? Same reason why in my JavaScript code, I might want to validate form data before sending it to the server. Because why make the user have to click submit, the server do all this work, and send back a response if our JavaScript code right off the bat can say, like, hey, your level has to be less than 50 and Charmander can't be more than 100 characters, right? So we might have the same validation logic in multiple places, but it's so that we can like catch the issues sooner to sort of make stuff more efficient. Yeah, great question. Um, let's see here. How are we doing? Do we want to take a break now and then look at making custom validators or keep rolling?
I think like a short break would be good.
Yeah, let's take a break. It is almost on the hour. So let's take a 10-minute break. What we'll do then is we'll make a custom validator. I think that will actually go relatively smooth because this is really the tricky stuff. Writing the validator is actually relatively straightforward. Then we'll look a little bit at testing, and then I think we should have 30 to 40 minutes of work time before part two of the lecture where you can get your hands on this stuff. Sound good? All right,
For sure.
awesome, folks. Yeah, great lesson, great questions. Have a good break, and I'll see everyone in 10. All right. So we've covered a lot of ground, right? We've reviewed models. We've talked about validators. We've talked about the key point that validators, validation logic happens both in our Python code and Django before we send the data to Postgres. And that's what the validators we create do. And then also how our model fields do indeed add constraints to the data schema itself in Postgres that is also like a later validation step. And then we saw how to use validators in our code. And this is by making sure we run this full clean method before saving. Now let's write a custom validator, and I think it'll be a lot of fun. So I'm going to go ahead and make a file named validator.py, and I'm going to put it here in the Pokemon app directory. Let me close out the README here. And the first thing I need to do is import from Django core from its massive list of exceptions or error classes, the validation error class. I'm also going to import from the Python standard library, the regex class. So we can do some regex. And sort of like you were saying, Chase, before, let's write some validation logic for our Pokemon to validate the Pokemon name. I can name it whatever I want, but it's a good idea to start it with a verb. It's a good idea to always start functions or methods with a verb. And so validate name is simple and straightforward. I'm going to write the error message that the user will see if it's invalid now, just to get that out of the way. And then I'm going to write the regex. And I'm a little rusty with regex, so I think I know what this does, but don't quote me on it. I think what we are doing here is we're saying the first letter has to be a capital letter, and then the other letters have to be lowercase letters, right, and not numbers. And I, I honestly get a little confused about what that R is doing, but I believe this is how we tell Python we have a regex here. And so you could put this into regexer, the website that I like. But what we're doing here is the Pokemon name has to start with a capital letter, and then it has to have zero or more lowercase letters. So our Pokemon name can't have numbers, it can't have spaces, so on and so forth. And let's use our regex now. So we'll do re.match, and we'll pass in the regex rule and the name that'll get passed into this function. And then, in fact, let's just kind of put this up here, and we can say if valid name. At this point, we can really return anything we want, but let's return the name itself. The important part is the else statement where we throw an error if the name is invalid. And this is required for every validator. Our validator has to have some sort of clause that will raise a validation error. And we'll pass it the error message. And in fact, let me rename this to be message. And we'll pass some params into the validation error so that the validation message can have some nice information that it returns when the error is thrown. And this is our validator, right? And it's actually not too wild. This is the main thing we need to do here. And I just want to check in to see if folks have any questions around the logic of this validation function and what it's doing. Cool. So now comes the fun part. Here in our Pokemon model, we can import from validator, import, validate name. And the same way I use validators here and here, all I have to do is for the field I want to use the validator for, pass to the validator's named argument a list and put in my validate name function, right? And so we're passing this function as an argument inside this list. It's a first class function. And Django will do all the work of when we run full clean, sticking the name in here. Now, because this only changes our Python code, I don't think this changes the data model. I don't think we need a migration, but it sure doesn't hurt to double check that. And it looks like it has indeed created a migration. I was wrong. But I highly doubt this is going to affect the data model. So migrations kind of do some extra stuff, as you can see. And now if I do Python manage py migrate, we'll apply the migration. And just for fun, let's go to pSQL. Let's look at our table. And we can see if I look here at the name column, that indeed no new constraint has been added, right? So Django keeps track of some of these validators and this part of our data model. This is not in Postgres. Now let's test this out in the shell. I am going to have to exit and restart the shell and go through the annoying step from Pokemon app models import Pokemon. And now I've got a Pokemon. And let's make Charmander. And let's break all the rules. Let's have the name not start with a capital letter and have a space in it. Right now, no problem, right? And we know that if I wanted to, I could do char.save and that would work just fine because we would be short circuiting this full clean step. We'll see in serializers in part two of the lecture how this gets automated more so that the full clean always gets run for certain things. But right now, just to see our validator that we wrote in action, let's run full clean. And this is awesome because I see my validator, right? Our custom validator, and it says name in proper name format. And indeed, that's our error message. And we see the param and we see the custom validator in action. How are we feeling about custom validators?
Is it good practice to, I guess, only have like your custom validators in this validator.py, or like should you put the built-in methods in there as well and call them from that?
Good question. Best practice is so the way that you can like add a bunch of validators in a list, like we see here and here. Best practice is get as far as you can with Django's built-in validators because there are a ton. Use them in here. So if I need multiple validators on a field like level, put them here in this list. That's how Django has kind of designed it for us to do that. Um, and then really only when I need a custom validator should I put it in this validator file and then import it and use it here. So, and like for example, we could write a custom validator that checks both min value and max value for level, right? But this is pretty easy to read. And I think readability is really the answer to your question, though it might not be satisfying. Like if I look at this, I realize we were just seeing validators, but once you get used to it, this is pretty comfortable. As another programmer, I can understand the intent here and the behavior of this model so that if you had to work with this code, you could do it relatively easily, right? Um, get as far as you can in here. If it gets really messy, maybe you need a custom validator, but you want to use the built-in stuff as much as you can. For something like this, where there's a regex, where we want to have a nice error message, it makes sense to have this be a custom validator and then use it. Because again, as a programmer, if I'm using this Pokemon class that someone else wrote, I can understand the intent of this code. I can see we have some validation logic for the name. And then if I need to, I can go and see what that validation logic is. Yeah, great question. I realize that was a long answer to a short question, but I'm very passionate about code readability. And in fact, that's like if you just focus on making your code as easy for someone else to read as possible, then it actually ends up solving a lot of problems. What other questions do folks have around validation?
I don't necessarily have a question on like validation, but I know you showed us that website for the regex stuff. Is there
Oh yeah,
any other like tools we can use to like understand regex? Because I feel like that's like a very good thing to have a grasp of.
it is. That regex site is great. Um, right, you can paste it in here. If I'm being real though, the best tool is probably ChatGPT. Explain this Python regex for me, right? Because ChatGPT not only will it give you the answer, but then you can talk to it and ask for it to explain more about something or go into more detail and stuff. You could say, like, can you simplify that to two sentences? I don't understand what the dollar sign at the end does. Is it necessary? Um, Regexer is really good. I honestly think this is also really good in this day and age, right? And the reality is, like before ChatGPT, I would just like be Googling regexes and looking for stuff on Stack Overflow, like Stack Overflow, regex, capitalize first letter, all letters. Um, and I would, it would take me like 15 minutes maybe because I usually honestly I'm not super strong on regex, and it really is good to learn it so you can build this yourself. But what I am super strong at is Googling for stuff and skimming Stack Overflow. So I would often find something that takes me like two-thirds of the way there and then modify it. Um, but when I would do that, I would then always like add a link to the Stack Overflow post I found it from and an explanation in the code of what it does. And if you look in our curriculum, you'll see that we have an explanation of the regex code. Like, and whenever I add regex, I would add this so that another programmer doesn't have to lose their mind figuring out what it does. Maybe not this detailed, but something along these lines. And so the sort of the Google Kung Fu skills are really important. But these days with ChatGPT, I think it's the Chat GPT foo skills that are really going to be your force multiplier in terms of learning this stuff. Does that help?
Yeah, yeah, it does. Thanks.
Yeah, I know. A long answer to a short question, but I like you all are at the point now where I don't think you have to worry about harming your learning with Chat GPT, right? I think especially in the first 3 to 5 weeks of the course, that's important because there is a lot of muscle memory to be built up. Typing out the code yourself is still important because it helps it really stick in your brain because your brain works differently when you physically do stuff. But this stuff is also getting complicated enough where, like, if you can start using ChatGPT as a sort of super powered Stack Overflow slash Google search to help explain things to deepen your understanding, that's only going to help you. And that's very much how like the industry is functioning now. Like I'm using Claude AI and I have it open all the time for everything. And also like there's an art to asking questions. There's all these studies that say if you have really good domain knowledge, like if you already understand something, you can use ChatGPT really well. So in fact, it will force you to learn how to ask better questions and think kind of more logically and specifically. So I at this point, as long as you're not generating massive amounts of code from it because that I think is counterproductive, right? Like, don't have it write a whole validator for you right now. But for like a regex or like a piece, or if something is wrong with my validator, I think it can provide a lot of learning value. Yeah, great question. Any other questions around validators or regex before we talk about testing? All right, let's write a couple tests. I think we've kind of ran through our slide deck, but just for fun, we can kind of finish through it. The migration slide, we've already talked about migrations. We've talked a lot about testing already. I think you all know this, but I do love this image. Tests won't fail if you don't write tests. The joke is also like the tests can only catch what you test for. They have limits, right? Um, there's a lot of studies that show it's cheaper to catch a bug before you ship it live. The same way where if you pseudocode or design stuff on paper, it's easy to fiddle with your design before writing code. And tests can help with all of that. As your programs get bigger, tests are helpful when you change stuff. Inevitably, you're going to have to change or refactor your code, right? Modify it. And the biggest challenge is actually introducing new bugs to code that was working before as you're changing it, which I know you all have experienced. And that's actually where tests can be your best friend. And there's a term, a test harness. And the idea is you write enough tests so that if you have to refactor or change a whole bunch of your code, the test harness tells you if you've broken something that already works. Um, so we have these models and these validators, but we want to write tests. And that way, if I need to change my model later, my test harness can tell me if I've accidentally broken something that I don't want to break. So let's write a couple tests and see how to run them. I know there were a couple of sticking points on this yesterday, so this will be good to see. We're going to put our tests inside this tests file here in Pokemon PY. We're going to import a couple things we'll need. We're going to need the validation error. And we're going to need our Pokemon model. And we're writing a unit test right now because we're testing one individual bit or unit of our code, specifically our model. And unit tests aren't perfect. They're not end-to-end tests that test the complete behavior of the program, but they're also cheap to write and cheap to run. So they can have a lot of value. And since the models are so low level and everything else is kind of built on top of them, we're at like the center of the onion. So we actually get a lot of value for writing tests, right? Because then everything else that uses this model benefits from that test. So I have to write my tests as a class. It needs to inherit from test case. And let's just test making a Pokemon instance. And I'm going to make a new Pokemon. And we're going to give it a pretty long description. And in fact, I'm going to copy the description. And if we hop over, and in fact, it's a good idea, I think, when writing tests, to do a split. And let's, in fact, get rid of this and give ourselves a little room here. If I look at my Pokemon description, our Pokemon length is probably still good. So right now, this should be a valid Pokemon. I'm hoping this will work just fine. Let's try saving and validating our Pokemon. Let's make sure the Pokemon exists. And here we're using one of the built-in testing methods with this unit test library. And here, let's catch any errors that might happen, specifically any validation errors.
Can you go over line 14?
Yeah, let me just run this to make sure I haven't done anything silly, and then we'll walk through it line by line. So let me hop over to my shell and pull up the browser a bit here. And I'm in my project directory. Should be able to run this with Python manage py test. And the test did indeed run just fine. It does look like I have an error, maybe in the description. Pokemon got unexpected keyword
So
arguments.
if none is a certain none, or is it not none? Okay.
Assert is none.
Oh, Morty, you're right. This should be is not none. That was
It's not
actually,
okay. Makes sense. Okay.
yeah, it's a typo. Yeah. I don't think that's what's causing the error in my test, but that was a different error that I had. I'm pretty sure here I must have a typo or something because this part seems fine. So in fact, let's just pass in the name and see how our test runs. So that runs just fine. And now let's add in the description and see if that works. So I'm a little surprised because we should have, it actually looks like we don't have a description column for the Pokemon. I'm not sure how that happened. I've got name level, ID name level, date encountered, date captured, captured. And if I go here to the models, there's very clearly a description models text field.
Did you migrate after you added that?
I would have thought so, but it would seem that that's,
Do you migrate tests? Or
we don't have to migrate for tests.
okay.
Let's try, just for my sanity, let's make another field called description two. So that's very strange to me. I wonder if I've, like, by accident been modifying the
Wait,
wrong Pokemon file.
when you're defining attributes, are you supposed to have a comma after them?
Oh, I am not. That is totally me being used to, there's so many different ways of styling the code. You may have caught the issue there, Kenny. Let's see how we do. Look at that. Two description fields. So, speaking, I must have been thinking about JavaScript or something else because I caught myself doing that a bunch of times and I've been correcting it and I totally missed it there. I never would have caught that. Good catch. Um, I don't know exactly how Python was interpreting it, but it clearly
But
wasn't
what's the
interpreting it
error?
as separate
There's
fields. Sorry?
Kenny. I really, what did Kenny see? I don't know.
Oh yeah. It's very subtle. At the end of the field, I had a comma like that.
Oh, okay.
Like if I had a comma here. Because my brain just wants to think of these as like items in a list or in an array, but they're not. They're class attributes. Um, between the Python and the JavaScript, it just that's how it goes sometimes. And it's interesting because it didn't throw an error, so Python must have been able to interpret it in some sort of valid way, but who knows what it thought it was. So now let's run migrate to create our migrations. And now let's see how we do with this test. Yeah, great eye, Kenny. Thank you. And now our test runs and it works just fine. I do need this to be a method that I call that will throw fail in case we do have a validation error. And let's test our custom validator and our Pokemon name. So let's test valid Pokemon name, and we'll name our Pokemon lowercase Pikachu, and we'll run this. Um, and then I'll talk through what it does and circle back to your question, Chase, about assert is not none. So here, this second test runs, and we see that it throws an error, right? Um, a self.fail happens, the test fails, we see improper name format. Um, in fact, I think this assert is not none works, but we can circle back to that. And I actually need to modify this test because I actually want this test to fail, right? Test that our validator throws an error for an invalid Pokemon name. So this part is good. We don't need this anymore. And To be honest, I don't even need a description, and there's a default description. So, it's good to get rid of everything unnecessary. So it's easier for other programmers to read this. And we'll just call this bad pokey name, in fact. So we can just see this in our code. And we expect that the full clean will run. And in fact, the full clean should throw an error, right? If full clean doesn't throw an error, that's bad. So I actually want my test to fail if this doesn't throw an error. And then when we get here, we are expecting an error. And what we are expecting, and we can use an assertion from our testing library, is that our error message will contain the message improper name format in error dot, and here we have to, let's print out, we can print out the error, and under the hood, it has a dictionary called message dict, and there's a property name. And now if I run this test, we see that the test runs as desired. This is our print statement here. And in fact, it's always a good idea to test that the test works. So let's change this to be a valid name, and this test should fail. And that's exactly what I want. So this should fail. And then if I want to, I could write another test, or maybe I do like another test like this, where what I do is I do, Pikachu 7. And so we can test for like all the different parts of our validator if we wanted to get fancy. And to answer your question, Chase, back in this original test, the purpose of this assert is not none is the
No,
goal
I
of the
kind of get it
test.
now. Sorry to
Okay,
interrupt.
perfect.
You just had it
No,
as
no, no, you're
the
good.
none, and I was like, wait, but it exists. And then Morty mentioned it too.
Got it. Got it. Yeah, that was a typo on my end. Totally. Any questions around testing? I know there were some issues folks were running into yesterday with running the tests. I I haven't been able to reproduce that. I don't know if anyone like Stephanie or Tim, if you guys figured out what the issue was going on there.
Yeah, I think it was Rachel that figured it out.
Oh, Rachel, thank you. Thank you.
Yeah,
My
it was
apologies.
it was just a pathing error. We had to when you were importing the test, you had to import it from a specific location, not just test. And the name of the test was it was
Got it.
Python something test and then the name of the test. Before it was just test, you didn't actually declare a name.
I see. Okay, so line one here we had wrong in the assignment code.
Yeah.
Got it. Okay, good to know. I'll make sure we fix that.
Oh no
And
no no.
I'm
So it wasn't that. It wasn't that. It was when you're running it.
mm, okay. Interesting. Yeah, I was able to get this to run.
Yeah. Python manage.py test. We had to actually after the test space and then the test name.
Got it. Yeah, so that works, and that runs an individual test or an individual test class. Yeah, interestingly, just test works okay for me running all of them. We'll have to poke around to see if we can make sure that's working for everyone. If someone does run into that, let me know. But yeah, other questions around testing? Cool. We do have a test assertions cheat sheet, FYI, in the curriculum, and that's kind of what I've been building through here. And so this, I think, can be really useful and is worth a once over to see all the different assertions that you have. It can be a bit of work writing these tests, right? It can feel a bit painful. Um, the nice thing though is if we end up with comprehensive tests for a Pokemon model, it gives us so much confidence when we're writing our code. Because when I'm debugging, the question is always which part of the code is the problem coming from, right? And if I'm able to run my model unit tests and know that all of my model logic is good, then it lets me focus on the other parts of the code when debugging. So there is an upfront cost to this, but if you pay the cost early on, it stays relatively small and it saves you time down the line. So, it can, being like comprehensive for every little aspect of every validator might be overkill. You might want to think about what's most important. Like levels is probably important. Do I need to check everything about the Pokemon name? Maybe, maybe not. Um, like if I was running a test, I would want to make sure this method works correctly and this method works correctly, right? And run a test and make sure like I create a Pokemon, I run level up, and then like grab the Pokemon from the database and make sure that the level has changed. Because then that gives me a lot of confidence in this code as I use it. I realize I ran pretty long here, and I do apologize for eating into our work time. Um, I'm going to do my best, but the Django module is also a big one. Why don't we take, should we take 10 and then we can come back for serializers? Let me pause the. All right. So today's been a big day, and the Django lessons are going to be big days. We covered a lot of ground with validators. Now we're going to look at serializers. So serializers are a really powerful tool, and we'll draw some diagrams for them in a minute. Um, and it's used for building web APIs because in fact, let's go back to this diagram here. If we look at the way the data moves around, when the data goes from the browser to Django, it's JSON, it's text, right? And then Django needs to turn that text into an object, into a Pokemon object. We do all our validation stuff that we learned about, and then it goes to the database. And at some point, when Django gets data from the database, the same thing happens, right? When a user, say, requests information about a Pokemon, Postgres sends the data here, and over here, I might have, uh, Charmander Pokemon object. But what I need to end up with is text, is JSON that gets sent back to the browser. And this is where serializers come in. So the job of a serializer is to turn JSON into a model object and turn a model object into JSON, right? The job of a serializer is to turn JSON into an object, and we'll just call it a model so we don't have to lose our minds talking about this stuff, and turn a model into JSON because that's such a core part of this process of if we're building, say, a REST API, getting data in and out. We're going to learn in a minute about a really useful framework called Django Rest Framework, but for now, we're going to sort of see the manual way of doing this with Django. And to do that, I am going to get a little screen real estate here so we can play around with the Django shell.
So serializers can like take backend data and make it formatable for the front end, but also like vice versa.
Exactly. Exactly. Yeah, great description, Chase. So right now, I've got Pikachu over here, right? And Pikachu has a name. Pikachu has a level. Pikachu has a status if they're captured or not. Pikachu has a description. And Pikachu is an object, right? It's an instance of our Pokemon model class. The way I'm going to show you now is not the way we're going to write this code, but it is to demonstrate a serializer in action. So, and if I print Pikachu, we see our dunder method, right? That says Pikachu is yet to be caught. None of which is useful if we need to send information about Pikachu to our React app, the way that the Poke API does. So again, what I'm going to do now is not the way we're going to write the code. This is just to demonstrate what a serializer is. I'm going to import from Django.core.serializers a serialize method. And I'm going to use it and I'm going to tell it how I want to transform or serialize this data. And I want to transform it into JSON text. And I'm going to pass it my Pokemon object, my model object that I wanted to serialize. But we get an error. And this error says type Pokemon object is not iteratable. The reason we see this error is because serializers are really, really powerful. Validation will eventually happen through a serializer. Serializers can also handle multiple objects. And if we go to the Pokemon API, excuse me, let's go over here real quick. And we think about getting, information for a Pokemon. And let's just maybe, I don't know, an ID of one. And we look at all this JSON that comes back. There's so much stuff here, right? Effect. Each of these effects might be, there might be an effect model. And so each of these is its own object. Um, Flavor text, all these other things. What's the route here to get a Pokemon? Is it like Pokemon/1? Yeah. So we haven't learned about relationships between models, but the same way that we can have foreign keys and relationships between tables and one-to-one and one-to-many relationships between tables, we will with models as well. And so we see here like this Pokemon, I think it's Bulbasaur. There's all these things. There could be a forms model, right? Um, Lord knows what half of this stuff is. So serializers don't just handle one object, they can handle many. And we'll see more about that in a minute. But what it means is when I use my serializer, I need to pass in an iteratable, something that can be looped through in a sequence. So for an individual Pokemon object like this, I'm just going to wrap it in a list. And we don't get an error. And if I type Pika serialized, we see a bunch of text. And in fact, our Pokemon has been turned into text in the JSON format. And this might look like we're looking at a list of with a dictionary of instances, but we're not. This is JSON text that is getting printed to the terminal. And if I do Pika serialized sub zero dot get PK for primary key, I get an error. String object has no attribute get, right? This is a string. And we can see this string has some stuff we don't really need, like the model name Pokemon app.pokemon. Yeah, it's okay, not great. Primary key is probably good. These fields are probably good, but it'd be nice to have more control over this, right? Um, this is where Django Rest Framework comes in. And so before moving on, I just want to check in and see what questions folks have around this basic concept and sort of this example. And how are we feeling thus far? Pretty good? Okay. Let's see how this really becomes useful because this is just sort of a toy example, right? For the rest of the course, we will be using Django Rest Framework. It's a really powerful framework that gives us lots of really nice tools. One of them is its own serializer model and letting us write a serializer class that does all sorts of really cool stuff. And this is what we're going to be looking at in just a moment. But first, we have to install Django Rest Framework. So let me just pull up today's curriculum and let's scroll down to Django Rest Framework and walk through the install process here. And the install process is relatively straightforward. We can see it here. We're going to have to install the Django Rest Framework dependency. We then do have to add it to installed apps in settings PY for our project. And this will then become a normal part of all the projects that you do because we'll use Django Rest Framework for everything. So I should be fine doing it in this directory because my virtual environment is activated. I do want to update my requirements.txt, so I'm moving a level up just for that. I'm going to do pip install Django Rest Framework. Then I'll do pip freeze into requirements.txt. And if we take a look at that, we can see Django Rest Framework version 3.15.2 is now in there. And now I do want to go to my project settings PY. And let's find installed apps. And what I like to try to do is this is all the Django built-in stuff. I try to have all the Django stuff there. You don't want to mess with the order of this stuff. By the way, I don't think it matters for installed apps, but it actually does for middleware and some other things. And then I like to add like the external dependencies. And then I like to have my apps last, so it makes it a little easier for me, but it doesn't make a huge difference.
Real quick, is the Rust Django framework actually Rust, the language, or is it kind of like Java with JavaScript, where it's just names? It has nothing to do with each other.
Oh, REST, sorry. REST as in REST API. Yeah, which we'll talk about later. It's the acronym is super long, but REST stands for representational state transfer, which is not worth getting into, and frankly is a longer term than it needs. Yeah, unfortunately, nothing about Rust here. It is a super cool language. Um, Definitely outside the scope of what we're looking at today.
And is this
Um,
what they're talking about when they say on job applications about RESTful APIs?
this is a tool to help us build a RESTful API.
Ah, okay, okay.
Yeah, we'll talk more about REST APIs proper as we get into it. The Geeks for Geeks one is probably a good introduction. Um, there's like more to it. Yeah, we'll talk about it properly. But we're already learning bits and pieces. Like if you just kind of look at this, you can kind of see things that we've already started talking about. Because the essence of a REST API is a convention for how we deal with HTTP requests between a client and a server. And we were learning about that. And we've started learning about GET and POST requests and the conventions of a GET request is to get information for my client, for my browser. A POST is to create new data on the server. You guys don't know it, but you've been following some of the conventions of how to design URLs for REST APIs already. If you see users/user ID 123, that's going to look familiar to you. And you can see here there's sort of a pattern for the URL identifying a resource, and then these HTTP verbs saying what we're going to do to it. So we'll learn more about that later, but we've been seeing bits of it along the way. And this will help us build one of those. And a key piece is The most common way to pass data around between the client and the server, between the browser and our Django server app, when building a RESTful API is by having that data be in the JSON format. And that's what serializers are going to help us do. Yeah, does that help connect the dots a bit more? Yeah, great question. Great question. Let me go ahead and do a quick run of my server to make sure I don't have a typo anywhere. And I need to move into my project directory. And I recommend always doing this after messing with settings PY. I'm not even going to open this. This is just to make sure I don't have a typo, right? I run the code, it works. I know I haven't made a programmer error, a mistake along the way. Now let's start working with building a serializer. And what I'm going to do is I'm going to build it, talk about it, and then we'll draw some diagrams and really dig into what it's doing. And for now, what I'm going to do is the same way we have models here in our app directory, I'm just going to make a serializers file. As we get more and more models, there will be a models folder and a serializers folder, and each model will live in its own file. For now, though, we don't have that many. I can just do serializers.py. And I'm going to need to import from Django Rest Framework serializers. And I'm a little surprised that it doesn't seem to be. There we go. I thought I had the default Python interpreter set. That's nice, by the way. The fact VS Code picked up on that I had a .venv file in my project root directory because the Python virtual environment was named .venv. So that's why it's nice to name it that way. So when we're importing from Django REST Framework, it's called, the module name is REST Framework. And so we're importing their whole serializers class. And I need to import my model. And now I'm going to create a Pokemon serializer class. And it needs to inherit from Django REST Frameworks model serializer class. And this is great. This is a whole class that Django REST Framework has designed specifically for making a really nice serializer from a model for Django. And the Django REST Framework docs are really good. So I can highly recommend them. Django, they're pretty good, but it can be kind of tricky digging and finding stuff. Django REST Framework is really good. And as you can see, like we're basically following along with their tutorial on serializer. And we'll kind of be going through this. And you can see that there's a lot of different things that are covered here. So as you start working with Django REST Framework serializers, you literally cannot spend enough time with these docs because serializers are probably the trickiest bit and their docs are quite good and it will help a ton. So let's build this one out. So I actually need to create a class definition named meta, as in metadata inside my class. This is just how Django REST Framework does it. And this is where a lot of the work happens. I need to tell the serializer. And so this is weird, right? We have a class definition, and inside that, another class definition that has to have this special name, and then a class attribute. And this is going to be our model. And this is just how you have to write a Django REST Framework serializer. Now, I add another class attribute, and these are the fields I want this serializer to work with. So I'm not going to list all of my model fields. I'm just going to list those basic ones. Now that I've done this, let's play with this in the shell. And I think what I'll do is we'll put the serializer here and the model here. So if we need to, we can see the model. For the moment, I'll close off the Explorer. And now let me go to our shell, and I will have to exit. And you don't have to do anything with migrations for serializers. No changes because I created a serializer. The serializer doesn't talk directly to the database. The serializer works with our model. I just want to see if folks have any questions before I keep on rolling. Okay, cool. Let's use this serializer and see what it can do. Um, so I'm going to need to do some importing. I'm going to need to import the Pokemon model. And let's grab Pikachu. And just for my sanity, I'll make sure I have Pikachu. Let's import our serializer that we just created. And it lives in the Pokemon app module, right? That's how Django thinks of this stuff. It's namespacing. And then it lives in the serializers module. That's the name of our file. And from that, we're going to import our Pokemon serializer class. And just to make sure my import was correct, I just wanted to print that out, and I see that I have an instance of this class. So now let's play around with this and see what it can do. I'm going to use the serializer and pass it an instance of our Pokemon. Note that it doesn't complain. I don't have to wrap Pikachu in a list. Note that the Pikachu serializer prints a whole bunch of stuff out. This is not JSON, right? This is actually an object. So we work with the Pikachu serializer object that we've created. And now we can do a bunch of interesting things with it. Here's something I can't do. I can't access, I can do Pikachu.name and it gives me an attribute on our model. The serializer doesn't work that way. The serializer is a little different. The serializer has put everything into a dictionary or a very dictionary-like thing. And to get an individual model field, if I want to, I have to access it from the dictionary. And we can see here that that's actually not that useful. And the data itself actually lives on a special property in the serializer. And this is, you won't have to directly use this, but it's good to know this because you will later, though this part, in fact, is important. It's this dot data property, and that has our Pikachu information. And if I do type Pikachu serializer.data, we see that it's not a normal dictionary, but a special return dictionary from Rest Framework, but it's basically a dictionary. So under the hood, Django Rest Framework makes a dictionary that they name data. And when we serialize a model, a Pokemon, that's where the data lives.
Adam, could you go back and show the actual command to serialize the Pokemon? You cleared it before I was able to write it down.
Oh, yeah, absolutely. So, in fact, let me. What was another one? Do we have Charmander? I think is in there. And we can do Pokemon objects get name equals Charmander. And all of this is in the curriculum document for today. And honestly, that's going to be the best place to look. And I need a closing parentheses. And now if I do Charmander serialize.data, we get Charmander's information. So we use the constructor or the dunder init method on our serializer class, and we have to pass in the Pokemon object to get a new instance of it.
So using that dot data, if you were trying to access the name, would it be like Charmander serialized dot data dot name?
Um, Very close. Dot name won't work because it's a dictionary, right? But I think if we do that, it'll work.
Okay.
If it
That
was a
makes sense.
JavaScript, you'd be bang on. But with Python, with the dictionary, we need to access dictionary properties with bracket notation or with the get method.
Is that a spread operator after
Mm-mm.
your Charmander serialize line?
No, that's just me forgetting to put a closing parentheses over here and the REPL saying this doesn't look like a finished line of code.
Okay.
Yeah.
So if you had just closed that parentheses, that would have been unnecessary.
Yeah. In fact, and well, I won't clear this, but let me run it again with the correct closing parentheses and we get Charmander again.
Okay, thank you.
Yeah, absolutely. Good question. Yeah. So when we serialize, we get like an object, like a serialized object. Our model data lives in a dictionary named data. And this is because we actually do a lot to like manipulate and work with the serializer. Um, Django Rest Framework has a separate library for working with JSON. Um, if I want to import it, this is getting a little ahead of ourselves, but I think this will do it. And whether it's this or other things, we use a lot of stuff. Like once you have a dictionary, it's not too hard to turn it into JSON, right? So JSON renderer dot render Charmander serialized data. Let's see if that does it. And it would if I didn't have a typo on this line. And I kind of combined a bunch of things into there, like my renderer. I could do this equals JSON renderer. I need to get a new instance of this, and I can do my renderer render, and I can put in whatever dictionary I want here. So what we put in is the data dictionary for our serializer object, and it gets turned into JSON. So the serializer doesn't actually directly deal with the JSON. It gives us a dictionary, but then the last step of turning it into JSON is pretty easy.
What about methods?
You mean on the model?
Yeah, because
Yeah, we
your
don't get
object
those
has those.
anymore. Yeah,
Okay.
we don't get those anymore because the serializer's job is to have the data and get the data in and out of the model. Yeah, great question. Though the serializer can do, well, actually, we might get, good question. I think we do. I apologize. I might have to eat my words there. Um, Let me show you why. So let me show you first of all how to get multiple serialized serialized objects. And I know I'm typing all this in the console, but just so folks don't get concerned, if you look here in today's lesson, you'll see pretty much everything I'm typing here. And so this is a good guide to go to. And what I'm going to do right now is we can serialize many things. Right? And if I look at all Pokemon, this is a query set, which is a list-like set of responses from the database of objects, right? Of Pokemon model objects. Um, and I can use my Pokemon serializer, and I can pass it all the Pokemon, but I do have to pass the special argument many equals true, so the serializer knows it's dealing with a bunch of things. If I don't, I'm actually surprised that worked. I would have thought it would have thrown an error. If we run it with many equals true, now let's look at all Pokemon serialized. Yeah, I'm kind of surprised this works. Long story short, you want to use many equals true because my guess is something else will break down the line if we don't. I'm like 90% positive on that because I've seen other errors pop up around it. But we can see that what we end up with here is a list of dictionary objects of all of our different Pokemon. So the last thing, and actually, let me just check in to see if folks have any questions. Cool. That one's pretty straightforward, right? If you're serializing a bunch of stuff, use many equals true. It will throw errors if you don't. I realize that particular command did not, but trust me, as we add more things in, it will. Um, the last thing we're going to look at is kind of the coolest part, and this is where serializers start to get a little fancy, and Tim, where we might in fact be able to use some of these Pokemon methods, and that'll be actually, I think, a good thing for us to test out. So let me do a little diagramming as a preview to talk about exactly what's going on here. When we create a Pokemon serializer, and let's get rid of the splits, we tell it the model to use. So inside there, and I think I'm going to use a circle for this, inside our Pokemon serializer lives a Pokemon model. And this means that over here, with Postgres and with our Pokemon table that has the long name, right, of Pokemon app, Pokemon, from inside our serializer, because it's got a model in it, we can talk to the database. So, Tim, I have to check. We may get the model methods, but what we get for sure is being able to save and do validation. So let's see what this looks like. And let me make sure, let me see what Pokemon are in our database so we can create a new one and not have it be someone that already exists. Actually, I can just do this in here. I don't know why I didn't think about that. Pokemon objects all. Okay, we have Charmander, Blastoise, Eevee, Pikachu. I need a little help here. What's a Pokemon that we don't have?
Ditto.
How do you spell it?
Ditto.
Ditto. Perfect. That name does ring a bell. We are going to add Ditto. What level do we want Ditto to be?
46.
Okay, I love it. Thank you guys. So I'm going to make Ditto a dictionary. This is a normal Python dictionary. I really shouldn't have been capitalizing these names in the database, by the way. That's a bad habit, but it's just so easy to do it, and it doesn't matter too much for learning. And level 49, right? And Ditto is a plain old dictionary. And again, Django Rest Framework gives us functions for turning JSON text into a dictionary and vice versa. That part is relatively easy. So if we kind of go back to our diagram here, the step of this JSON text going to Django, that's already happened. And then this JSON has been turned into a dictionary, but what it's not is a model, right? It's not a Pokemon model. Does that make sense? And is everybody tracking? How are we feeling?
Can you say that one more time?
Yeah, absolutely. So if you think about now that we're dealing with, it's really a distributed system, right? Because I have a client, I have a server, and I have a database, and they could all be running on different computers over a network. We have a system. Even though it's a simple system, it's surprisingly complicated. And the way to think about systems is to think about the flow of data. And if I'm, as the user, in some form in the browser, creating a new Pokemon, the way the client, our React app running in the browser, sends data to the server is with JSON and an HTTP request. So we do something like, post Pokemon. And that gets sent from the client to the server. And then Django is going to turn the JSON into a dictionary. And then we're going to turn the dictionary into a Pokemon serializer. And then the Pokemon serializer will use the model to put our new Pokemon in the database. Does that help break it down a bit, Chase?
Yeah,
Yeah,
it does.
great question. And there's a lot of steps here, right? This really is a system. It really is a distributed system. The client server architecture is like the most classic distributed system architecture. So we get to pat ourselves on the back for doing some fancy stuff here. And I just want to check in if folks have other questions around the flow of data here. Cool. So this part, turning the JSON into a dictionary, I'm just going to pretend that's already happened. That's some other Python code. It's taken the JSON, it's turned it into a dictionary. I now have Ditto, which is my dictionary, and we're going to turn it into a Pokemon serializer. How are we feeling about this process on a scale of like 1 to 10?
Maybe probably about a 5. But you didn't include all the data in Ditto that are the required fields that the other one have. Is that going to throw an error?
Great question. The answer to that is to look at our model and we can check it out. If I look at date encountered, I see it has a default value, as does date captured, as does description, as the second description I made when debugging, as does captured.
So you should be fine.
Exactly. But that's a good thing to think about. And the answer is always going to just be like, let's take a look at the model and see if the fields have default values or not. Yeah, that's exactly the kind of thing you should be thinking about. So once you write the code, it will become a little clearer. Right now, you know, there's already been some Python. It's gotten JSON, it's turned it into a dictionary. Let's turn our dictionary into a Pokemon serializer. And the good news is that this is relatively straightforward. Serialized Ditto is a Pokemon serializer that we're creating a new instance of. And all I have to do is pass in as a named argument for the data for that data dictionary, our dictionary of stuff. Right? One line of code, but there's a whole lot going on here. And if I do ser ditto dot data, we see that actually this error is really a good one. At the very bottom, it says you should call is valid first or access initial data instead. And this is actually taking us to where we need to go next. So let's search here for is valid in the Django Rest Framework docs. And it should be, is this part of our serializer? Yeah. Um, so our serializer can actually save stuff to the database, but we have to validate it. And there is an is valid method. Um, and if I can find the API reference, I would really like to actually have us just go to that docs to see. They kind of hide it here, but what they say here is important. When deserializing data, you always need to call is valid before attempting to access the data or save an object instance. So right now, like this example is with the comment where they've created a comment from some data. We need to call this is valid method so that the serializer can figure out if there are errors or not. So let me go ahead and call is valid on my serialized ditto. And we get true. And now if I do serialized ditto dot data, it prints it out just fine. And if I do serialized ditto dot errors, it's an empty dictionary. And here's the fun part. Let's take a look at all the Pokemon in our database. Ditto's not in there. I can do ser ditto dot save, and it, this is the serializer being even more safe. It doesn't want us interacting with this dot data method because it doesn't want to put bad data into the system. I think what I can do is run is valid again. And now let's see if I can save it. Nope. If you need to access data, so it's not going to let me do it at all. So let's just recreate the Ditto serializer. Now let's do ser Ditto is valid. Now let's do serialized Ditto dot save. And we get a response back that looks awfully like the dunder string method of our Pokemon class, right? The Pokemon ID and Ditto. And if I go here to Postgres, I see that Ditto's in there.
So
So
why wasn't it working before?
yeah, so this the serializer has a model in it, right? And Django Rest Framework adds a whole bunch of stuff onto the serializer. And part of what isValid does is it runs all of that full clean stuff that we were talking about, all of the validation logic. Like for example, what's another Pokemon name?
Gengar.
How do you spell that? Gengar?
Gengar.
Gengar. Let's make a Pokemon serializer for Gengar. And I'm just going to put the little dictionary right in here. And we'll just do name Gengar. So this is a bad name, right? This is going to throw an error. And just for safety, let's mess up the level too. And the level will be, 5,000. And I forgot an L in my serializer. So I've got Ser Gengar. Let's run is valid on our Gengar Pokemon serializer. we get false. Let's try to save their Gengar. We get an error. You cannot call save on a serializer with invalid data. If for Gengar we look at that errors dictionary, we in fact see the error messages. If I hop over here to my Pokemon model, in fact, let's open up my validator, my custom name validator in proper name format. We see that error message right here, and we see the level validation logic as well. So when I run is valid, it runs full clean. It does all of the validation. So the serializer helps protect our data integrity. It won't let us put invalid data into the database. And one of the ways it does that is it doesn't want anything touching that data dictionary. And in fact, what I should have been doing is the serializer, it has a validated data dictionary, but there's nothing in this one because all of this data is invalid. If we look at our Ditto serializer, note that that data is valid, right? So there's a couple levels here, but the main thing to know with serializers is once I get the data in, I want to run is valid. And actually, what's one more Pokemon?
Relax.
How do you spell them?
Sonrlax. Sno. My bad.
Snorlax. Got it. Right. So let's make a dictionary for Snorlax, and we'll make Snorlax valid.
If you only had one valid object in that dictionary, then when after you run all that, is your validated data dictionary only going to have that one attribute?
I think so. Yeah, we can test that out. So let's do serialized Snorlax equals Pokemon serializer data equals Snorlax. And so serialized Snorlax validated data,
Mhm.
we can't, there's not even anything there until we run is valid because the serializer is protecting the validated data. So we have to run is valid. And this runs full clean that does all of our Django validation, right? I get back false. Let's go to Ser Snorlax validated data.
Nothing.
It looks like it won't put anything in there, which kind of makes sense because maybe some fields depend on values for some other fields. So they're probably erring on the side of safety. So that's no good, right? We can see the error. What we would have to do at this point is we would have to create a new Snorlax serializer with our valid data. So I would have to fix the error, recreate my Snorlax, run my validation logic, and then I can save Snorlax. And if I then go to pSQL, I see here that Snorlax is in there. I feel like this can be a bit tricky. There's a lot of OOP stuff going on here. So I want to check in to see what's on people's minds and what questions folks have. Because we're going to be using tons of serializers, tons and tons and tons of serializers.
This feels just like a huge brain dump that it's just going to require practice to figure out how it's going to
Yeah.
flow.
Yeah. I think this is one of the trickier things. So, and let's see, in fact, let's do serialized Snorlax. And what was the model method? level up. Let's see if this works. I don't think it will. Yeah, we don't get the model methods. So here's the thing to remember about a serializer. Inside it, it has the model. We don't get to do everything with it, but we get to do some things. And there's data, and there's validated data, and there's errors. Right? And we can run is valid, which will sorry, I don't know what was going on there. Is valid will run the model's full clean method and do all the validation. Any errors get put in the serializer's errors dictionary. Um, Once all the data is valid, it's put in the validated data dictionary. We should not access the data dictionary directly when creating models from JSON and dictionaries, right? The serializer protects data to make sure it only will contain valid data. So we never put invalid data into the DB. It's basically impossible with Django Rest Framework serializer to put invalid data into the database. It does everything possible to make that impossible. And the tricky bit is remembering that inside it, it's got a model. So you can think of it as inheritance. It's not doing inheritance, but the truth is, like, if instead of this, you all saw something like this, like Pokemon serializer, Pokemon, that's like multiple inheritance, it might make more sense. Or if we had it something like this would probably make more. I guess we kind of end up with the same thing. Yeah, we kind of end up with the same thing. We would really need multiple inheritance for this to work. Um, where we're inheriting from two classes so that the Pokemon serializer has everything that our Pokemon model does. Um, for sort of basically design choices, the Django Rest framework did a little differently using this sort of method called composition. Or if you saw this, it might make more sense, right? Because then, I could do, self dot model, or maybe I do Pokemon serializer dot model. I don't know if this looks a little more familiar from the OOP code that we've seen, but they're all different ways of accomplishing the same thing, which is the Pokemon serializer class has our Pokemon model. And so the Pokemon serializer's job is to make sure that the data is valid going in and to help us turning into a dictionary coming out. Um, does that help at least a little bit in thinking about what this serializer is and what its job is?
Honestly, I think you just explaining some ways that you shouldn't do it made it more confusing because you intermix stuff that we were already
Got it.
familiar with. That's the bad
Yeah,
way.
got it. Yeah. Oh, you mean like all the other ways with the classes or things like that?
Yeah. Yeah, you said, well, it would make more sense if you saw it like this, but that's not how it is, and you can't do it that way. So I don't want that in my head. I honestly just looked away from the screen while you did that.
Got it. Okay. I appreciate the feedback. That's good to know. Um, yeah, there's probably a way to build it like that, but they didn't. I'm honestly not exactly sure exactly what they're doing in here, but this is also where I think it's okay for this part to be magic right now, to be totally honest. The important part is understanding that what this magic does is it gets us the Pokemon model and the specific fields. Like, for example, I don't have my description field and my other field and my other stuff. And if I want that, like if I want to be able to use the serializer to get a Pokemon description in or out, I need to add it, right? So it actually gives us a lot of control. And we'll see that as we do more and more with serializers. This is a whole lot, and I do think today's assignments are what's going to help the most. I'll share this diagram as you work with serializers. Just kind of come back to this. I think that will help. Today, it's just continuing with the school API. I shouldn't say just because that's a lot right there. But the part one assignment is going to be um, building out the model more and adding validation. And then the next part is adding some serializers and writing Django serializers. And you'll see here, we give you the shape of your JSON and your dictionaries, and we want you to create some serializers to work with those. So I would encourage you all to make sure that you get to the point where you're working with the serializers today. Today will be a pairing day. I know that when there's a lot of new concepts, it can be tempting to want to kind of dig in and figure it out solo. I do think that working together on this will be a good one. And I'll send the pairs out in just a couple minutes. Um, do folks have questions about serializers or anything else before we wrap up?
So this seems like it's something we should have like really try and understand because it's like such a large part of the RESTful framework.
Yeah, we're going to be using serializers a lot. But the good news is we're building it up step by step. So all you have to focus on right now is the assignments for today. This whole Django curriculum model just builds on stuff one step at a time. So you can see here the learning objectives are actually really helpful here. Like today's job is, I think we're all relatively comfortable with validators. Get your hands on the code, write some validators. Serializers are a bit more confusing and magical, I know, but install Django Rest Framework and follow along. I would honestly just follow along with what we have here for serializers, for building one, and make a simple one and get your hands dirty with it, and that will help with your understanding. And we've got tomorrow, we'll be looking at relationships, but we'll be getting lots of reps and sets in with serializers as we keep on going. So today's a good day to get started, but we'll be seeing a lot of serializers as time goes on. And if you haven't, Francisco made a pretty amazing diagram that kind of shows, you know, everything, literally. And you can see serializers are kind of hiding in there, and there's more stuff we're going to get to. But the key thing is to remember how models and serializers connect, right? And then the model can talk to Postgres. And as long as you keep, I think, those things in the back of your mind, it'll help smooth the road. So right now, just focus on writing code and doing the assignments. And what you'll find is that it's really like the writing of the code that'll help lock this stuff down. All this other stuff we'll get to in time. Um, we're at the point now where I'm a firm believer, as much as I love reading and really digging into docs, the way to learn this is through doing, the same way you would if you're learning an instrument or like learning to kick a soccer ball. So that's the one thing, and I think you all have been doing a great job of that. Let me go ahead and stop the recording and let's break for lunch because I realize I ran a little long.